welcome back.
Hello.
Hello. All right, so today we're going to be looking at rhombi and squares. This is the word rhombi. It's plural for rhombus. So whenever you have a whole bunch of rhombuses, you wouldn't say rhombuses, but if you had a whole bunch of rhombus shapes in a room, hanging out, having a party, it would be a rhombi party.
Yay.
So rhombi rumble, that's when they get into an argument. Okay, a rhombus is a four-sided shape. It is a parallelogram, and all of its four sides are congruent. So not only is it going to have all the properties of your regular parallelogram, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other. Not only is it going to have all that mess going on, it's also going to have all its four sides congruent and two additional properties, which are our theorems. We'll get into those in a second. Yep.
Do you have an extra one of those?
You can have that one. That's already all colored and written on. Otherwise, there's some at the pickup table. Okay. Rhombuses can be made even more. Rhombi can be made even more special by taking their corner angles and turning those into 90 degrees, and you get the square. So if a square is both a rhombus and a rectangle, it's a square. Okay? If I hand you a shape and I tell you, behold, this shape is a rhombus, then you know two things. First, that the diagonals are going to be perpendicular to each other. That is, they're going to form a right angle. That means their slopes are going to be negative reciprocals. You also know, hi, shape is a rhombus. The diagonals are going to bisect the corner angles. Since it's a parallelogram, these two big angles here at N and Q are already congruent. But because this is a rhombus, this diagonal is going to split this angle Q into this piece and this piece, which will be congruent. And this piece and this piece. And all four of those things are congruent to each other. Okay? Yes? Good. Now, if I gave you shape and I said, hi, this is shape, tell me, what is shape? And you're going, I wonder if this shape is a rhombus or not. Here's how you tell. If you know that the shape is a parallelogram or can prove it's a parallelogram, then all you have to do is show the diagonals are perpendicular, and boom, you get to say it's a rhombus. If you've got a parallelogram and you can somehow show that the opposite angles have been bisected by its diagonals, you could say it's a rhombus. Or if you can show that the sides touching each other, the sides making a corner, the consecutive sides, are congruent to each other, you can tell that it's a rhombus. Okay? All three of these only work if you already have a parallelogram in front of you. So you either have to be told it's a parallelogram or you have to prove it's a parallelogram before you can use these to say it's a rhombus. Clear? Okay. And then the last one is if you've got some sort of quadrilateral and it's both a rhombus and a rectangle, it's a square. Okay? So these are the 5 theorems and 2 definitions that we're going to be using for the examples today. Ready? Here we go. Did you want a blank one to copy down the examples and I'll go get another one? Yeah? Okay. I'm happy to do that. Oh, I grabbed way too many copies of that. I meant to grab one and like 4 came up. Okay. Here we are. So we are looking at this example down here. This is the bottom of the back side of the first page. And we are told to determine whether parallelogram ABCD with vertices, those are the corners, guys, at these particular locations on some graph paper, a coordinate plane, is a rhombus, a rectangle, or both. Okay? And I'm using the same sort of color coding for rhombus and rectangle. Square is colored in both to show that it has to be both. Okay, so here's what we're going to do. Here's my shape. I'm told it's a parallelogram. Okay, freebie. I know it's a parallelogram. So now all I have to do is show that either the diagonals are perpendicular or the consecutive sides are congruent. Which do you want to do? If I'm looking for least amount of work and maximum payoff, is that what you'd like? Totally go with the slope formula. Because slope formula is two numbers subtracting, and then you divide. And the distance formula is like the square root of, and then stuff subtracting and squaring, and other stuff subtracting and squaring, and then you add stuff, and then, right? It's way too much work. So totally slope formula, which means I need to show that this diagonal is perpendicular to this diagonal. And if I can do that, then I can say it's a rhombus. And my work for that is going to be here. Okay, so this is going to be my work for, is it a rhombus? All right, let's do it. Okay, I'm going to zoom in on my work. We're not going to see the picture anymore. We've already decided which is the diagonals. So here I go. I'm just going to mark these real quick. I'm going to use the slope formula, which if you recall from previous section is y2 minus y1 divided by x2 minus x1. I've labeled them up there at the very top, and all I'm doing now is very carefully trying to substitute. And I get a division by 0. I just broke algebra. But whenever I get a slope with a denominator 0, it means that line is a vertical line. Sorry guys about the blanks. I don't know what happened. Sorry. All right. This means that if I want the other line to be perpendicular to this, I need it to be horizontal. And for it to be horizontal, I want the slope to be 0. So I'm going to run the slope, and I'm going to hope it's 0. I don't know if it's going to be 0. But if it is, it's perpendicular, and this thing's a rhombus. Ready? Here we go. Same formula. Do I need to write the formula again for you guys, or you got it? No? Don't need to write it again? Nope. Okay. So I'm going to follow this same formula that I wrote here in the pink. Okay. You can divide 0. You cannot divide by 0. Okay? 0 on top is okay. 0 on bottom, totally not good. Remember, whenever you have a slope of 0, what kind of line is it?
Horizontal.
Thank you. And so this means that these two lines are perpendicular. And so our sentence becomes, since line segment AC is perpendicular to, that's what the big upside down capital T means. Since line segment AC is perpendicular to line segment BD, parallelogram, that's what that symbol means, ABCD is a rhombus. Let's get ready to rhombus. We did it. We have a rhombus. But we were asked, not only do we want to know if it's a rhombus, we want to know, is it also a rectangle? And in order for it to be a rectangle, that makes it a rhombus. We want a rectangle. Put on your rectangle. Huh?
The diagonals?
The diagonals need to be congruent. So I'm looking at the diagonals again. Notice how we have the diagonal names listed and they have no symbol over them, which means we're looking at their distance. Notice how these things are horizontal and vertical lines, which means they're on the grid line. on the grid lines. This means I don't have to run the distance formula. I could if I wanted to, and I need to if they're not on the grid lines, but since these are, I can just count. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. It's a rectangle. Counting only works when your lines are horizontal or vertical. You cannot count the squares if your lines are at a slant of any kind. At that point, you must run distance formula. Okay?
So only because the lines are straight.
Only because the lines follow the grid, horizontal and vertical, was I allowed to just count. Otherwise, I'd have to use the distance formula, which is, hang on, I gotta hold my tongue right for this. That. Okay? Lucked out, because it was on the grid lines, I could just count. But because they're the same length, this thing is a rectangle. So this was all us checking to see if we have a rectangle. All right. Is a rectangle? Yes. Is a rhombus? Yes. Which means this thing is a? Beautiful. And I'm writing square in both colors of rhombus and rectangle, so that it's really easy for your brain to be like, oh, it has to be a both. Because that was always the hard part for me. Feeling comfortable about this? Let's flip the page. Let's try it again. Bless you. From the, we have nothing but a coordinate grid and a list of numbers, and we have to figure out what we want to do. Okay? So turn the page. We have two choices. We have the left column and the right column. Which one would you like?
The left.
The left? All right. So reading the directions, given each set of vertices, that's the location of the corners, guys. Determine whether symbol ABCD, okay, what does that symbol mean?
Parallelogram.
Thank you. If you did not recall that this symbol meant parallelogram, please, at this time, label it now. So we want to know, is this parallelogram ABCD, is it a rhombus, a rectangle, or both? Alrighty. And we're going to list all that apply. So we're going to do like a yes-no column. And if we get a yes or no, we're going to explain why we said yes or no. All right, so first things first, we're going to draw the thing. All right, looking at my coordinates, I don't see any negatives anywhere, which means I can put my origin way down here on the lower left. Because there's no negatives. I can just focus on the positive. Now again, this is just a quick sketch, so I don't have to be like really perfect about it. All this is going to allow me to do is see where things are. And maybe from there, I don't know, I guess I could do something. Maybe I'll be able to count something. I don't know. We'll see. Again, I don't have to draw it super neat. There it is. Done. Next, we're going to check to see if it's a rhombus. In order for a parallelogram to be a rhombus, what needs to be true?
Congruent sides.
All congruent sides, which means any two consecutive sides being congruent would give us a rhombus. Because these sides are not on the grid lines, we'd have to go to distance formula. Right? I heard the shock, gasp of disgust. Yeah, I don't want to run distance formula either. So what else could be true to make this a rhombus?
If we made the lines, if it's
Perpendicular.
The two things are perpendicular.
Two things are perpendicular. Which things?
Diagonals.
The diagonals. If the diagonals are perpendicular,
AC and BD.
which is just a slope thing,
Yeah.
then I totally have a rhombus. So you know what? Slope is so much easier to calculate than distance. Totally going to just let's just do slope. I don't even want to deal with it.
Yep.
Okay, so slope for BD. Do you need me to write out the formula again, or are you feeling comfortable? I don't need to write it. Okay. So just gonna blast through this one. I found a division by 0. That's an undefined slope, and that means that this particular diagonal is vertical. My picture seems to hold that up. Okay, I'm gonna do the same thing to AC, just to confirm. All right, I got a slope of 0, which showed that that was horizontal, which means these two lines are perpendicular, and therefore this is it's a rhombus. So I'm going to write yes next to rhombus, and now I'm going to write my reason why. It's a rhombus because the diagonal line segment BD is perpendicular to the diagonal line segment AC. And I can check off rhombus. Next up, is this thing a rectangle? Congruent diagonals or perpendicular consecutive sides.
Since they're straight and horizontal, we can literally just count.
Okay. Since these diagonals are vertical and horizontal, they're laying on the grid lines, which means I can just count. I don't need to go to any formula. 1, 2, 3, 4. 1, 2, 3, 4. Is it a rectangle? Yes. What's the reason?
Because they're congruent. The diagonals are congruent.
Because the diagonals are congruent. Diagonal BD is congruent to diagonal AC. Is it a square? Why?
Because it's rhombus and a rectangle.
Because I got a yes on rhombus and on rectangle.
So therefore, it's all of the above.
See above. Or both rhombus and rectangle? I mean, whatever you want to say here to make it clear that you're recognizing the fact that a square is both a rhombus and a rectangle. We're good. Cool?
Yep.
All right. I definitely totally want to do number 4 with you. We're at the top of the page. These are it. These are the last 4 examples, and then we're done for the day. I would like to do at least one more of the other 3. Please choose the one of these other 4 that you're like, I'm intimidated. I really want to see this one.
4.
We're definitely doing that one. Totally had you covered. I read your mind.
I don't know.
Number 2. Okay, I like number 2. Number 2 comes with a hashtag spoiler alert. I actually wrote it. So we'll do number 2 first, then with our spoiler alert, and then we'll do number 4. Okay? So number 2 says if line segment AB is 26 and line segment BD is 20, my orange is dying already. Then it wants me to find AE. And so that's what my marked up figure looks like right now.
Oh, it's 10.
Okay? we have 26 on the big outside, we have 20 as the diagonal. We're trying to find that other half piece diagonal that I've colored in blue. And I heard, oh, I think it's 10. Okay. We're going to go through and calculate to see how close we actually are. All right. I know the diagonals bisect each other because this thing is a parallelogram, and parallelograms diagonals bisect each other, which means that since this is 20, how much is this piece? This little piece right here is 10. Now, because this is a rhombus, I know which lines are perpendicular. AC and BD, the diagonals. So there's a right angle sitting right there. What kind of shape did we just mark right here?
Triangle. Right triangle.
A right triangle. A triangle that has a right angle. Are you ready for your spoiler alert?
There's one.
We can use the Pythagorean Theorem to help us find the sides of right triangles. And I heard a groan, which means that you've seen it before and you hated it the first time, yes?
A squared plus B squared equals C squared.
A squared plus B squared equals C squared. That is indeed the Pythagorean Theorem. We're going to write this down, and hopefully by the time we're done with this example, that groan turns into a, oh, I totally get this now. Okay? Okay.
Correct.
Keep me updated on that groan. Okay. All right. Here's how you know which side is which. A and B can be any side you want. No one cares. But C has to be a particular side. Go to the right angle and then shoot a laser out of the corner of that box. And whatever side you run into, that's C.
Okay, this is C.
That's C. Shoot a laser out of the right angle box. And that slanty one, that's C. Okay, that's the hypotenuse. And suddenly my guest auditor from, not auditor, yeah, guess it'd be auditor, she's kind of sitting in with us, had me last year, went, oh, I remember this. She got excited. Okay, so I'm going to just fill in what I know. So here is C's value.
What is B's value?
Right here.
Oh, so it's
I get to choose which one I want to be, A or B. But since I wrote that in the same color I used for B, I'm totally just going to use that one. It doesn't matter. No one cares. You can totally put A and B in whatever order you love the best.
also, since we don't know A. Oh,
Which is what we're looking for.
We saw.
We're just going to self-ray, and that's going to be the length of AE, and we're done. Okay, so here I go. I'm gonna do that, guys. Here I go.
it's kind of that
This isn't that bad at all. You're probably gonna need your calculator apps though, because I have no idea what 26 squared is.
bad.
How? With an A,
It's 676,
I think.
I think. Yeah.
Yes, it is. Okay, thank you. And now I'm gonna subtract the 100 from both sides.
Minus 100.
And then I need to undo a square power. How do you undo a square power?
Sure,
Beautiful. So I need the square root of 576.
Oh, okay.
Yeah, calculator app. I don't know.
Square root this.
Square root this thing. Square root this thing. Square root this thing. I don't know where your calculator is.
576. Square root. I think it's 24.
He thinks it's 24. Someone with a calculator app, let's confirm, because I'm not saying that you don't know it and you're not
Yeah,
awesome
that's
enough.
24. It's not 24.
It's not
24
20
times 24 equals 576.
And we just found what we were looking for.
So, yeah.
Spoiler alert, we won't actually play with Pythagorean Theorem legitly until chapter 8,
Which is not that far, right?
which is not that far away. It's going to be the end of the 6 week, start of next. And then we're going to do really weird things with right triangles, so be ready for that.
It's gonna shoot more lasers.
More lasers. All right, last things last is number 4, and we are done for the day. We're looking at the measure of angle CDB. All right, back to my figure. CDB, that's this angle right in here. I'm told that the measure of that angle is 6y. And then I am told that the measure of angle ACB, this angle right here, that angle's measurement is 2y plus 10. And from just that information alone, I need to calculate the value of y. This does not look like it's enough information. Except that I know two things. One, that this is a rhombus, which means it's also a parallelogram. And parallelograms have this beautiful, beautiful property that says that these two consecutive angles are supplementary. What did supplementary mean?
That means when you add them together, you get 180.
Yep, and I heard that from about 3 or 4 different voices scattered throughout the room in different ways of saying it, and I had started nodding at each of you, and I just let you guys finish saying it at your own time. So yes, you add them together, you get to 180, but there's a problem. I don't know what this angle is, and I don't know what this angle is.
Wouldn't it be the same?
But it's the same as the ones that I've already made that color because this is a rhombus. And in a rhombus, the diagonals bisect those corners, which means if this is 2y plus 10, then this is 2y plus 10. And if this is 6y, then this is 6y. And so all 4 of those little tiny angles added together must give me 180. And now I have an equation that I can solve. So I'm going to come down here to this empty space. Come to this blank space, baby. We'll write an equation. Okay, that was a really horrible song. I tried, guys. All I'm doing is I'm just taking those angle measures that we had from before and I'm writing them down, trying to keep the color coding so that it connects to your brain in terms of what I was color coding from above. And now I can solve this for y. I'm going to go pretty quick, so please triple check my arithmetic.
Arithmetic.
Yes, please, because numbers.
Y equals 21.3 by...
What? Stop.
I'm good? I got 1 nod. Did I do okay? Did I get the right numbers? Yes. I subtracted right?
Yeah, wait, you got Y equals 10?
I got y equals 10.
Huh.
No.
No,
What did I mess up?
oh, wait. Why did you get... Oh, because you wanted to find the whole...
Wait, that's right.
Oh.
Yeah, wait, yeah.
You're right.
You're right.
Okay.
Right.
Okay. I had a moment of, what did I mess up? All right, that's all I had for you guys today. Thank you so much. We'll see you in the next one.
See you in the next
Video.